Welcome to tutorial number 172. In this tutorial, we will talk about another command for creating sheet metal parts. In this tutorial, we will talk about the lofted bend command, which we see over there. We will have a look at the cases where the lofted bend can work and when it can't work, and then we'll have a look at the main two types of the lofted bend lofted bend and formed lofted bend, and see the types under the bend lofted bend, which are chord, tolerance, number of bends, segment length, segment angle, and see the difference between them and see which type will fit your requirement. The sheet metal lofted bend is almost similar to the solid features lofted, boss, and lofted cut, with some major differences. And if you hover over the lofted bend, you will see that the lofted bend in sheet metal works between only two sketches. So let's start making two sketches. Let's make on the top plane a circle and give it a dimension of 100, and make another sketch on another plane. Let's make a plane parallel to top plane with a distance of 200. Click OK and draw a center rectangle. Give it dimension of 175. Make this tangent to the circle. So here we have two profiles or two sketches. Let's hide this plane. So in the original lofted bend or lofted boss, these two profiles will work. Also in the surfaces loft as well, the loft between two sketches will work. But in the sheet metal, as we knew before, that we should have a gap, mostly for bending gap or welding gap. So let's first try to see. We have click on the lofted bend. You have bent and formed. But first, let's try to select this sketch. You will notice that you are not able to select any of these sketches. So exit from the lofted bend and let's make opening gaps in both sketches. Edit that sketch, normal to, and let's make center line and opening gap. Make this rectangle for construction and give it 2.5. And then trim the circle over there. Fix the point over there. Now it's fully defined. Exit, and the same thing on the second sketch. You can convert entity or again create a similar rectangle and trim the entity. Click OK. So now the sheet metal lofted bin is supposed to work, but you will notice later that it will not work, probably for one reason. We will talk about it. Select lofted bin. Now select that sketch. You notice that you are able to select that sketch and select the second sketch. You see it worked, but if you hover or zoom in, you'll see there's a gap over there and the bin is not fully covering that gap. If you click OK to see it clearly, you'll see there's a gap over there. So the reason for that you need to have bending radius instead of a sharp angle, 90-degree angle. So delete that lifted bin. Go to sketch 2, edit, normal 2, and add bending radius in the form of fillets. So let's make it 10 millimeter. Click OK and exit from the sketch. And let's try now to use the lofted bin. Select first sketch and the second sketch, and you notice there that you got the lofted bin fully working. Here in the first options you have bin and form. Let's first click on the form. You'll get just a very simple loft without any chord lines or angles, and we will have another example about it later in this tutorial. And let's discuss the first option, bend. And if you roll down the profiles which we already selected, sketch 1 and sketch 2, and here are the facing options. So depending on the manufacturing method which is going to be used to produce this cone or duct, here are the options, or depending on the shape wanted. So the easiest way to know the difference between these four types is at looking at the figure of it over there. So the chord tolerance is the distance between the max distance between the linear segment and the arc. To show this segment and the arc, let's exit from this command and flatten. And if you notice over there, there is straight lines or segments instead of arcs. It is clear over there, and let's unflatten and go back to lofted bin, edit, go to the chord tolerance, and we can decrease or increase the value to 5, so it will be clear to see the segment and the chord arc over there. So the maximum distance, it is 5 millimeter between the arc over there and the segment. And the second one is according to the number of bends. So it is almost clear. So depending on the number of bends, you have here 4 corners, and you can decide the number of bends in each corner. For example, now we have 2 bends which represent this one over there and one over there. If you increase, you can notice that increase. Also, you can change the type of bends in each corner by selecting the dot over there. So if you click on the dot and let's select number of bends and let's type 8, you will see that the number of bends are 8 over there and it's applied on that corner. And let's go to the next corner and try to apply a different type. And this time let's select the segment length, which we showed you before. Click on segment length and it is here 5 millimeter. Let's click OK, and the segment, you can see it if we flatten the part. Let's click OK and flatten. And here you'll notice the maximum distance is 5 and here it's shown 4.7, and adding the bendings radiuses, so it will be almost 5. So the 5 representing the maximum value. Exit, and let's go to the angle between the bending lines. Edit the lofted bend again and move to the next corner, and let's this time select the segment angle. So this is the angle between the segments. Here it is 30, then let's make it 40, and you see the angle is 40, and let's make it less 10, and it is clear the angle between the bending lines increasing and decreasing by changing the angle value. So now this is brief look at the types, and with practice it will be easy to differentiate between them. And the rest of the options, we already talked about the thickness of the sheet metal and the bend radius. When you are done, click OK. Now we will have another example where we can use the lofted bend with the form type. We have the famous example by Alex, and it is found on the internet, and here he has the instructions how to form this part. And as you notice on the second part, use the lofted bend. And if you notice this shape, there is no angle or bending segments, so the type used to create this shape is the formed lofted bend. And also it will be a repetition for the unfold, the cut, unfold back. Here the dimensions are in inches, so we will assume that they are in millimeters multiplying by 10. So 4 inches over there, we will assume it 40 millimeter, and 0.1 inch, we'll assume it to be 1 millimeter, and so on for the rest of the dimensions. Here the circle is 20 millimeter, let's say, and 30 by 15 ellipse. So start a new part and make a second reference plane 40 millimeter far from the front plane, as you see over there. So features, reference plane, and reverse, offset and make it 40 millimeter. Click OK. On the front plane, we'll have a circle with a gap. Let's make a center line to make it easier to deal with it. So let's check the dimension of first sketch. You will have 20 millimeter diameter and the gap is 1 millimeter. So the radius should be 10 millimeter and the overall diameter is 20 millimeter, and the gap over there 1 millimeter, and let's make them symmetric about the center line. So here we have the first sketch is fully defined. Exit and go to the second plane and insert sketch, normal 2, and here we will need an ellipse 30 millimeter by 15 millimeter. Here you can see partial ellipse with the gap. So the distance from this point to this point is 30, and from this point to this point is 15. Let's make this horizontal and the gap one millimeter, and let's make them symmetric around center line. Convert entity and for construction symmetry. So now we have the ellipse fully defined. And the second option or instruction is to use the lofted bend. Go to lofted bend, sheet metal, lofted bend, and this time we will pick the forme type. This sketch and this sketch, and the thickness, let's make it 125. And as you notice, it is similar to the shape we saw. If you convert it into pen, for this shape, you'll see it didn't work. So let's make it form and the number of bent line. So we keep it to the minimum 1. So make it smooth and click OK. So here we have the initial shape of the exercise inside that plane, as we can see it here in the picture. So here we have a similar shape. So, and it said that use the unfold. So as we learned before, so you said unfold. Let's go to the unfold, pick that edge, and the bodies or bend to unfold is that body. Click OK, So now here is the unfold shape of that part. So now let's create the holes. We have almost 3 mm hole, 80 holes. So pick that face, start a sketch, normal to, and let's draw a circle. .12. Let's make a dimension of 2.5, or better make it 5 and 5 over there, and go to feature, extrude cut, click OK. So now we have the hole. You can make the holes all at once, but I would like to make the holes tangent to the curve. Go to feature, curve driven, and select the curve and features is this hole, and we need 10 holes, and let's make the distance 7.5, and that will be okay. Click OK, and now we need as you notice from the shape, we need 8 on the other side. Now we will make a line, a direction line for the second pattern. So we have the face with an angle. We can make a center line between this angle. Make a sketch on that face, normal to, select center line, and make it an angle of 7 degrees. Exit from the sketch, linear pattern, the direction. We'll pick this 7.5, 8 pattern, the features, let's make the distance, make it 4, 5, click OK, and now let's unfold or fold back the part. Go to sheet metal, fold, select the edge is selected, the body, and here we have the required shape. And let's hide that sketch. So if you compare it with the part over there, you'll notice that we got a similar shape.